Hello, let's make Tetris.
But before we begin, here's a little showcase of what are we going to achieve today. So as you can see, I'm controlling the blocks and there is this collision between blocks and the whole playing area. I mean, you can see, but I am pressing left arrow button in order to move the block. The blocks are going in a turn-based phase because as you can see, there is a timer in every block that is counting up to 0.9 seconds and then it's moving the block down. You can move blocks down faster and you can only move one space sideways at a time. And also there is an implemented way of rotating the pieces as it is implemented in the original game. Also, there is obviously a way to complete those lines, and as you will see in a moment, yep, that's the first line completed. We can do this several times, obviously. Yep, that's the effect we'll be achieving today, so a fully playable version of your own Tetris game. And all that in Unity using available tools without any third-party assets.
Okay, so we start with creating a new project. We call it Tetris for obvious reason. Okay, so when the scene is loaded, let's prepare our area by changing the camera flag to solid color and the background will set to dark gray. So we set the scale. Let's make it orthographic and the size of 30. Alright, so right now we'll create okay, so I have created a very basic sprite in Paint, Microsoft Paint, which is basically a 16 by 16 square with a 1 pixel wide border. And in the settings we'll change its texture type to sprite 2D. The pixels per unit will set to 16 so that it's one unit wide and tall in the game, and the filter mode to point no filter. We'll press apply, and now we can create a new object. We'll create an empty and change its name to block. Inside we'll create another empty, we call it rig, and this one will be useful and necessary, as a matter of fact, to the method I will be implementing when we'll be rotating the piece. Okay, and inside we create a sprite 2D. For the sprite we choose our outline. As a matter of fact, if you don't want to use the outline the way I'm using it, change to 2D to see it better. You see, I like the outline thing. However, if you don't want to create a sprite like this, you can just go and create sprite square and then choose this square. So if you want the outline or not is up to you. I will use the outline. Alright, now let's create 4 pieces of this block, and using this tool we will move them one place at a time so that we get our first block called block Z. I will call it block Z for the later use, or Z1 as a matter of fact, because we'll be making 2 pieces of it, both identical with the difference of them being mirrored on the axis, y-axis. Alright, so we've got our first block, and in order to have it be possible to control the block, we'll create a component we call block logic. I like the nomenclature that I call whatever the name of the object is plus logic.
Okay. So in the update method of the block, we'll handle the movement. And by movement, first of all, let's do the moving sideways. So here we'll check if the player pressed left or right arrow key. So we'll use the boolean function input dot get key down, and here we'll put key code, let's say left arrow as the first one. So this function of class input get key down returns true during the frame user presses left arrow key. The difference between this one and the function get key is that it only returns true once. And if you are still holding the button, it doesn't return true anymore. So this thing inside our if condition bracket, it will be triggered only once. So here what we want to do is we want to simply move the game object by changing its transform position. So we want to move it down, sorry, we want to move it left. We want to move it left by deleting vector, new vector 3 with values 1, 0, 0. And it should do the trick. The same will happen in else if, and we'll go input dot get key down, key code, right arrow key, right arrow. But this time we will copy and we'll add this vector. If we go and run our script, our game, we can see that indeed it is working. You cannot see it, but well, I'm pressing every time. Every time the block moves, I'm pressing the button once. If I hold it, I press and hold it, it only moves once, so one unit to the either side, and that's what we want to achieve. Okay, now let's do the dropping down. So drop. As a matter of fact, we'll distinguish two types of dropping. First will be autonomous, and we have to introduce a float. As a matter of fact, let's do something like creating 2D object, and this 2D object will be our playground. And right now let's disable the sprite renderer. We don't need it for the time being. Let's call it playground ground, and let's add a game logic script here, because what I want to do is I want to introduce a value that should be shared among all blocks. So it's better to put it as a static public in this game logic object, I mean class, but eventually an instance. So we go with public static float drop time, and let's make it 0.9, and also let's make another one, static float quick drop time, and let's make it 0.05f. Generally those two values will be used here in our update method in the block logic, and first of all we need to introduce float timer value, and let's set it to 0. We'll do something like this. We'll check if the timer is greater than game logic dot drop time, then we will drop our piece, and by dropping piece we'll do the same trick as we did here, but we'll not we'll change the vector to 0 1 0. But we'll change the values of the vector we will subtract to 0 1 0 because we want to change the value on y-axis, right? And as a matter of fact, I said we want to introduce the quick timer, the quick drop, because we've got two types of dropping. First one is autonomous, so whether our timer, and first of all we have to update the timer, so we will increase the value of the timer by 1 times time.delta time, and we'll increase the timer, and if it exceeds this value, then we will move our piece, and after moving our piece we have to reset the timer again. But also there should be a situation when we can, but there's also a situation when we want to drop our piece quicker by pressing, for example, down arrow. So we'll introduce another if condition, but this time we'll also put input dot get key this time, and for key code we'll go down arrow. That's not the only condition. The other condition is that we want to add the same thing like here, but instead of drop time we'll go with this quick drop time, because we still want it to behave in a steppy behavior way, so it will not go continuously, because without this thing it will go instantly down, and we don't want to do that. We want it to drop one by one, quickly, frequently, and the frequency will be determined by this value. And yeah, let's put the same stuff here because it's the same. And also we don't want those two values to collide with each other, so let's put this one in else if. So the determiner will be if you are holding the down arrow button. Alright, so far so good. Let's get back to our game and let's see if we can control the piece mid-air. It is going down, we can control it mid-air. If we press down button it goes faster and then continues to drop autonomously, which is good. Alright, let's introduce a bool movable. Let's call it movable. Let's set it to true. We'll cover this whole update method in this bool condition, because at some point we'll set the movable to false, which will determine whether the block hit the ground or not. The ground or the lower layer of blocks. And let's, for the time being, now what we want to do is we want to prevent our block from going outside the playground. For this thing, let's enable the sprite render again. Let's change the scale on X to 15, on Y to 30. Let's change the color to maybe bluish. Yeah, a little bit aqua. Yeah, something like this. Alright. First of all, let's make our block pieces one order in layer. So we have to choose all of them and make them one. This one is 0, so it will be always behind. Alright. at the time being, our playground is at position 0, 0, which is here, and our piece is also at position 0, 0. And when it comes to coordinates, there are several things to do. We can, for example, treat corner 0, 0, and here it will be 15, 0 as our down layer, which is good. So we can put it here. We'll set 7.5 and 15. This way our piece will be at position 0, 0, and it will mean it is, sorry. Okay, so we've got our block in the correct position, and the stuff that's with coordinates will be dealt with in a moment. And although it can be tricky, you will see in a moment that after some tweakings, it will work just fine. But before we go further, let's add one more thing, which is rotation. So rotation, as a matter of fact, rotation is not difficult at all. We will go with another if condition statement. No indexer, no. Go with input, get key down, and this time we'll go with key code space. And to be honest, we'll go just rig. Oh yeah, we don't have rig yet. We have to input public game object rig. We'll put the rig in a moment. Transform, not transform Euler angles, and we'll decrease the value by new vector 3, 0.0.90, which is a right angle turn to anti-clockwise. If you add, it will be clockwise. It's like up to you. It doesn't really matter. Here, in this rig game object, we put our rig, obviously, so that our block, which is moving, it won't change its rotation, because then changing position would be awkward, to say the least. Only this one will change its rotation. And no, sorry, we will be rotating clockwise. I was mistaken. All right, so let's see how it goes. I'll have to move the camera. So putting down moves it faster, going to sides moves it to the side. When we press space, you can see it's rotating, and the rotation is quite tricky because, as you can see, it is rotating around this one centerpiece, which is how it does in the real game, which is strange, yes, but due to the fact that the coordinate system has to be based on like whole numbers, then yeah, it has to be this way. And it sometimes looks a bit awkward, but in the original game it's implemented the same way, so who am I to judge, right? Alright, one more thing, let's change the color to orange of those blocks. Let's change the camera to, and here 15, maybe let's make it smaller, like 20. That should do the trick. Okay, we need more blocks. Let's make a folder for blocks. Block, yeah, all right. Let's grab the parent block and let's put it inside. As you can see, we've created a prefab, so when we delete this guy, we've got still the same piece that we can mash over the playground, which we will not do, so we go Ctrl Z to previous position. We'll duplicate 7 times this piece, because I want to create a second. Let's use this tool. I want to create another pieces, meaning the different
shapes of the blocks. Yes, so we've got our first Z, Z2. The only difference will be it will be mirrored. That's Z2 right there. We revert the position, the rotation's like 0, so we put it here, original prefab. So we've got another one already. Z here we'll go with C, which should stand for cube. Okay, let's also change the color to be greenish. Block C, we revert the position, original prefab. This one will be block I, which will stand for the line. All right. Let's change the color to blue. And also revert the position and original prefab. This one will be block L1. This one L2. Yeah, so L1, we'll just change this one. And also the color will be green, purple, violet. Yeah, can be violet, right? And yeah, revert the position, make a prefab, block L2. We'll change the color to color picker the same. This one here, this one here. Sorry. Revert, original, and the last but not the least, I believe the iconic T block, which will make this kind of search and rescue red going into pink a bit. Call it T obvious. Call it T obviously. Revert the position, original prefab, and we're set. So right now let's delete them all, and yeah, let's stick to our piece and let's make sure that it doesn't go outside the borders. Before that, we need the actual border size, so we'll go with public static int width and height will be 30, width will be 15. All right, so let's create a method here, bool, and we'll call this method, how can you call it? Let's call it check valid. It should return true if the move is valid. We have to check the validity of the move for every piece that is inside the block. All the blocks take up to 4 pieces. I mean, all of them take exactly 4 pieces. But we'll use a generic for each loop, which will check transform, not tracked reference for God's sake, transform sub block. We call it sub block in what? In our rig, because our rig is
game object. So we'll use transform of it. As a matter of fact, that's the very nice trait of transform, because this game object containing those 4 children has the information about children in this transform component. So as you can see, we can go and iterate through every block, and we have to check whether the block is not outside the boundary. And we'll do it with a very easy if check. We'll go call game object, and sorry, not game object. We'll call this sub block transform not parent position x, and we'll check if the x is not bigger than game logic with, or if subblock transform position x is not smaller than 0, or if subblock transform position y is not smaller than 0 as well. And if it does, if any of these does happen, we'll return false, meaning the validity of the move is not good. Alright, but when do we call this method? I say anytime we do move our piece. After we move our piece, we check if the new position is valid. If it is, then it stays. If it's not, then we have to restore to the previous position. So we'll go, doesn't really matter, go if not check valid. So if the check valid returns false, then we will revert to the previous position. So just change the minus sign to plus sign. So it shouldn't move anymore because it will be looped inside this this gate, this logic gate, where it will revert to the previous position every turn, let's say. In order to prevent that and like free the memory, we'll use this movable flag, which we'll set here to false, so that it will only revert to the previous position once, and then it will just not calculate the position anymore, because it's no point. Alright. Here it will be the same, exactly the same. However, in sideways, we'll not reset the flag of movable. Here we have to make sure it's an opposite of this one. Also here we'll go with not plus but minus. And the same story goes here, but we will increase. Yep. So yeah, that's it for this part. Let's see how it goes. Okay, I cannot reach outside. I can reach outside by one piece, so I forgot I have to change it. I can rotate here, I can rotate here, I can rotate. I cannot rotate more because it will... Okay, and right now I have touched the ground, so the game for this block is over, which is also a kind of thing we wanted to do. Alright, here if it's greater or equal, because there is one, it should be one less. Sorry. It should be one fewer. All right. Right now, what we want to do is we want to create a method that will create spawn block. So we go with void. No, we will make it public. Void spawn block. and we'll instantiate block, and we'll give not block logic but just block. We don't have it introduced a block yet, but we will in a moment. And as a transform parent, do we need any parent? We don't, so we'll not give any. Okay, let's introduce a game object array which will be called blocks, and that's it. Here we'll go with something like we want to randomly choose a block. All right, and in order to do that, we want to choose the block randomly. I mean, the type of the block we want to spawn, we want to choose it randomly. In order to do that, we introduce a helper value of float type, and it will be random range from 0 to 1 f. Let's be sure to put f here so that we choose from 0 to 1 with the float precision. Otherwise, if you go 0 to 1, it will be integer and it will always choose 0, which is not what we want. And I mean, it could be, no, it's not important. And we go with this guess, and we will multiply it by blocks length. This way we'll always receive an index of the blocks array, no matter how many pieces are there, which is fine. And we'll go with blocks, and we'll put guess. I mean, we have to cast it to int, obviously. No, we do not cast it to int. We want to use math. Math f dot round to int. Sorry, floor to int, not round to int. Not, sorry, floor to int, and we put this little guy inside, and it should work wonders. And in the start, let's call spawn block once. And also, anytime we change the movable trait to false, we want to create a new block. But first of all, let's add a game logic reference. We call it game logic, obviously. In the start method, let's find it in the scene. There's always one type of game logic in the scene, so it will always find the correct one, which is fine by me. I like to do it this way, so every time the game object of block type is spawned, it will find the game logic, the motherboard of the game. This is a game manager. And here, game logic dot spawn block, so it will spawn a new one. This one we'll put here as well. Let's go to the game. Let's delete this little guy. Here in the game logic, I forgot that this array should be public, because we cannot see it in the editor. Let's put 7 pieces. Let's put all 7 of those inside the array. And let's go test the game. We'll go down, down. As you can see, we are randomly spawning different blocks. And for the time being, they are respecting the boundaries of the playground, but they are not respecting the boundaries of their own. So, which is kind of, intolerant of them. But that's something we'll be working on now.
In order to have the blocks recognize each other, we have to introduce a mean of storing the data, and we will choose, I will choose, you can do this as you wish, however I suggest you do it the same way, especially that you are following this set course, so I suppose you are doing everything like me, so let's stick with that assumption and let's go on with creating an array, two-dimensional array of transform. You could also make a nested array, however, two-dimensional is, I don't know, easier. There's actually no difference in those two arrays, especially for the situation we are handling right now. So new transform, and let's put here width and height. So it will always be the size of our world. If we increase the world size, it will automatically scale, which is fine because everything should be automated. As many things as possible. Let's delete the update because delete this bad comment as well. We don't need to update in this game logic script. Let's go back to our blocks, and as a matter of fact, we want to check whether we are inside what? We want to check the validity of the move, and here, besides checking whether we are inside the playground, we want to check whether we are not touching any piece that has been already, put to rest by our moves. In order to do that, we've got to use a trick, and we are checking every sub block. So let's just check if this sub block, if the game logic and the grid of the game logic at this particular position of our sub block, we will go with math floor to int. We'll put our sub block position, yes, because it's transformed already, position X here, so that's 1, and the other coordinate will be the same, so we'll copy it, the difference of changing X to Y. So we check our sub block position X, we just make it, we make floor of it and change it to int, so we just kind of round it to the lower integer, so in that way it will be always correct. So we check whether at that position in the grid there is already a registered subblock. If there is, so if game logic does not equal to null, then we will return false. Otherwise, if it's null, so if it's empty, then it will return true, and the validity of the move will be positive. Also, we need to create another not bool but void method of registering block to our grid, and we will register our block after the validity of the move has been proven false. So after we check the move and it's false, we restore to previous position, and the previous position is the last position it can be, where it can be, and it's still correct. So then we will register that position as our final and we'll put it to the grid. Yes, so here we'll go with register position, register block, and yeah, and in register block we'll do something like this for each once again, and we'll copy this one because it's literally the same. We're still iterating through every block that's inside our rig, and
for the every block, we'll go and call grid, and here we have to put x and y, some x and some y, right? And for the x and y, we'll do the same like here, because we'll put the position of our sub block, but it will be just rounded to the lowest, to the smaller integer. And for this one, we'll assign the reference of this particular sub block. And it should be working wonders. Let's see. It was outside the boundary, and that is because right, it's above, but we want it to spawn above. So let's check if the not if, but we'll add another condition, and this condition will be that our sub block position y should be smaller or equal, not smaller than what? Game logic dot, not this one, game logic world, sorry, height. Yes, if it's smaller, only then check, because if it's higher, then it can be higher. Alright. -1. Oh yeah, one more thing. That's the beauty of having such conditions be in particular order. First, we want to check whether we are inside the play area. Then we check if the piece exists. So this way, it will never go outside the play area. Alright. Alright. So they do not recognize each other. But did we register? No, we did not. Forgot to register here. Alright. And it is working wonders. As a matter of fact, the game is nearly completed. Yes, it is nearly perfect. So yeah, as you can see, we can play the game for a bit to prove its functionality. But the last thing we want to do is we want to create the very Tetris thing, which is having the lines, which is checking whether the line is complete and removing the line if it is. Okay, so we'll go to game logic, and here we'll create another public method, public void. We call it clear lines, and we will clear all the lines that are filled, and we'll move the line above down. Yes. So every line above the line that is cleared will be moved down. And alright, so here we'll go with for loop, and we will start from 0 and we'll go until height, right? And here we'll check if, and let's create another method helper method, call it bool is line complete, and we call is line complete, and only if it is okay, and we want to pass the I, which stands for height, and maybe let's call it Y for the sake of transparency. We pass Y here, we receive Y, and we return true, for example, so that we do not have this error, which I don't like really. Here in check line complete, we'll use for loop. We'll iterate through X this time until with, and as a matter of fact, we are going to check if grid xy equals to null, then we'll return false because it's not full. And after we check all the pieces, and all the pieces where some things were not null, then we will return false. We'll return true, and we'll go here. So this helper method is complete. I will leave it open for the clear view. Alright, and if the line is complete, we'll call another helper method. We call it destroy line. And after destroying line Y, obviously, after destroying line Y, we need to move lines up from Y. And yes, we have to implement those two. So I go Alt Enter and then press Enter. We implement, maybe not private, just void, doesn't matter. Remove the throw. Okay, first move lines. No, sorry, first destroy lines because it's easier. We can use the same for loop here. We copy paste it because here we do not return. Let's say if it's not null, then this grid, it's always not null. So we just go with destroy, and let's say grid x, y, and that's really it. Sorry, not destroy the grid because the grid is transform, but we want to destroy a game object that's attached to this piece of a grid at this particular coordinates. All right, now let's go to move lines, and that's the really only tricky part of this algorithm, because as you can see, it's pretty clear and straightforward. So here we will iterate through all the lines starting at Y and going up. And we start at Y, so we iterate through X, so from 0 sideways to the right hand side until width once again. And, or as a matter of fact, I forgot, we start another for loop. This one we'll have to put inside. So we start with I. The I is Y at the beginning, and we go until height. So we are going up. We start from 0, and there is some line that's complete, and we we take this line, and all the lines up we move down. So we start with Y. There's no need to move down lines that are lower than the line we are clearing, which I hope is obvious. Okay, so we check whether the piece above the piece that was currently destroyed, because right now we are going through the line that we cleared, that we destroyed. It is destroyed, but we check the piece that is higher. So we go with X, so the same position on X axis. However, on Y, we check a higher value, and we check whether it is not null. If it is not null, so if it's not empty, we go with grid, and we go with x and y equals to grid x, y plus 1, then grid x, y equals, game object, transform position, we move it by new vector 0, 1, 0. So the same as if it moved on its own autonomously. And then we'll make the grid that's higher. So here we'll make it null again. And if it was null, then, well, nothing happens. But for the sake of it, we'll make our null. So if the higher one was null and we destroy this one, then we'll make this one null. And as a matter of fact, that's it. Like, really. But we have to call this method here as a matter of not game object, game logic. So as far as the game logic is concerned, we have to call this clear lines method anytime we would create. Actually, before spawning blocks, we could also call it so inside here, but well, let's stick to this one. Okay, so we put this one. We'll now want to complete a line. All right, not this one, but, and we did create. However, there was a bug because this row or this line, as a matter of fact, should be it should go down, because, and also this one, although it they cannot move. Oh yeah, so there are a few bugs that we have to fix. Sorry, we don't do that. And also we start with this one. Why? If line is complete, that destroy it. Then move lines starting from this one. All right. Once again. Okay, and it did work, and as you can see, the pieces are being respected by one another. So, to be honest, this little tweak, as you can see, that's some master play here. Can I do this? No, I cannot. There's too much to ask for. Oh Jesus. So as you can see, the game is really working, and now what you need is some skill in order to, do some stuff with it. Alright guys, so thank you for watching, and it's been really nice for you to stay along and look. Yeah. I think I'm really going to enjoy this game. If you want, you want. If you want, you can stay. If you don't, you can like go do whatever you guys are doing. I'll stay here, play this game a bit. I really liked it back in high school. Jeez, it is nice. Okay, thank you guys for watching and see you in the next tutorial, whatever it will be, whenever it will be. Cheers.